I know how to answer this.
You're supposed to, but you ain't gonna get
All right.
Versus man.
There is a handout with it. And we basically, you should have a handout with it. You didn't have a handout with it?
Nope, no. It was just one
Wow,
piece
you
of
just had the test, didn't you?
paper. Yep.
How does that look for you? Is it pretty complicated?
How many pressure switches are located within the solenoid pack/TRS assembly?
Yeah, how many pressure switches are located within the solenoid pack /TRS assembly on this particular
Is it
vehicle?
3?
Huh?
Is it 3? I say it's either 3 or 4.
I say 4.
Where are you coming up with 3 or 4?
That's what I personally think it is.
Hmm?
That's what I think it
I
is.
bet you if I had a head.
I mean, I'm probably wrong, but I mean, you know.
This right here is a 45 RFE. 45 RFE transmission. 45 RFE.
I'm gonna go with 5.
So what's these numbers stand for, Mr. Richard?
They basically, every manufacturer has got a different way of doing the transmission nomenclature. You know, like you'll have the 4L60E transmission that you worked on your truck was 4-speed linear, which is rear wheel drive, and 60 is the torque rating, and E means electronic. If it's a 4T60E, it's transverse, 4-speed transverse, meaning it's the one that comes like in the Oldsmobile, 60E. The odd thing about that Oldsmobile has got a pretty substantial heavy-duty transmission in it because it's a fairly big car. That little 2005 Cobalt that we had in here that had that funky little 4-cylinder eco engine in it, it has a 4L60E transmission, just like that big Oldsmobile got in. That transmission is really a bear.
That looked like a nice car if it got the steering fixed.
I want to motor that.
They got the steering fixed.
Oh, they did?
Yeah.
Probably
She
a nice
needs tires
car.
for it. But the fact is, that's what they do that. Now, you asked a really good question there. Now, the interesting thing about it, usually the numbers will be related to if it's got an E on the end, it means it's an electronic transmission. If it's got like a 4 in there, it'll be a 4-speed. You know, they got a 5R55E that's a 4R44E. The Ranger's got a 4R44E in it. Sometimes it doesn't mean anything like you would think. Like the transmission in the big Bronco is a C6.
Is it basically just an identification number for them?
More or less. I mean, you just,
6-speed?
no. It's just a plain old 3-speed automatic. I mean, you would think there would be something there, but there's not. Okay, so you got a C6, you had a C4, you had a C3. I mean, those different transmissions, you had different torque ratings, and they were totally different transmissions. There was a C5, there's a C3, C4, and a C5. A C4 and a C5 were almost the same transmission, except the C5's got a piggyback valve body that's on the valve body that makes it shift smoother and this kind of thing. And the C6 is it doesn't have overdrive. Then you had the AOD, which stood for automatic overdrive. And then you got a RE401, which is the one in like a 91 Nissan hard body pickup truck, which is an automatic, and an RE. The E's electronics, the second letter, I guess, on that one.
Man, that sounds all so confusing.
RE4. Well,
memorizing it like Mr. Russo got it.
yeah, I don't have them all memorized, but AOD, the one that y'all are working on over there in that police car. Originally, the original version of that thing came out in '79. It was an AOD, automatic overdrive. And the way that it locked the engine all the way through to the rear wheels, it would actually have a shaft that was hard connected to the torque converter that went down inside the transmission. And whenever there was a band that applied in there, you wound up, with your third gear would give you the straight lock up all the way through, and then fourth gear would engage the planetary that would give you your faster output than you had input and all that kind of stuff. But it doesn't have a clutch in the torque converter on that one. Everything was done down inside the transmission, see? That's what it was. But it had an extra shaft coming out. The turbine shaft was a different shaft. There was you had the stator support, you had the turbine shaft, which was hollow, and then coming out the middle of it, you had that shaft that went right down into the middle. Something else you need to remember when you're working on an automatic transmission is you take them, anytime you have splines that go into, like if you've got a shaft that goes into some splines, particularly down in the torque converter, it's a good idea to take that turbine shaft and stick it down in the torque converter and turn it to see if those splines are stripped out or loose. See what I mean? If they are, then even if everything else is good on the transmission all the way through, if you've got the splines wiped out in the torque converter, it ain't going nowhere.
So I wonder what that could mean, though.
Well, it basically means that you need a torque converter. Yeah, that's all. That's all it means, really. You just replace the parts that are wiped out. It's not like you're trying to design the transmission. You're just trying to fix what's wore out and broke. The RE401 that we did right after I came here was a little hard body Nissan pickup, and she said it was driving just fine. We went over a railroad track, and all of a sudden it wouldn't pull anymore. And so we pulled it out and looked down in there. You could look down in there with a flashlight into the torque converter, and you could see where the turbine shaft went in the torque converter. The splines were wiped out. Well, that one had a whole bunch of metal in the pan too. And usually they will have. When it wipes out splines, you're going to see metal all over the place, and you got to get all that out of there. If you go to a place where they rebuild automatic transmissions, this actually the bench where they rebuild the transmissions are going to be just absolutely squeaky clean. You won't see a speck of dust anywhere. Now, you may see beat up metal and all for topping the bench, but they're not going to build a transmission on a bench that's wood that's got splinters coming off of it. They don't want rags, a lot of shop rags around that's got little threads and fibers coming off of them. Because all of that stuff, any of that little stuff can get in there and stick valves in that valve body, and then you got to go back in there and fool with all that. And if it's squeaky clean and somebody knows just how to stack it back together and they look at every part, you're not going to have any trouble when you go back together with it. If you watch somebody do transmissions that really knows what they're doing, you'll see them rattle that stuff. Well, let me tell you what you do. You'll see them rattle it around and stick it down in there, and they say, well, that don't really feel right, and then pull it back out. And it's not about cramming it back together the best way you can so that you can beat the pump into it. You know what I mean? And if you ought to be able to grab that turbine shaft and turn it when you're done. That's just the way it is. And you could do that when you built your transmission on that thing right there. All right, so all of that stuff is something that the big package. Most of the time when you start trying to teach people how to do automatic transmissions, they cry and walk away because they're a little harder than they thought they were going to be. And manual transmissions. Probably the courses that I teach here that people, that more people don't like the transmissions just because they like they don't mind usually doing engine performance work. They don't even mind doing engine work. In most cases, like some of the engine work is about like automatic transmission works. Like some of these cars got these timing chains that are like a Swiss watch, or they got timing belts that run around all around all kind of pulleys, and you got a whole bunch of timing marks you got to line up. I mean, sometimes people gripe about that a little bit, but you have to be tougher than that car is, and you got to stay in there until you get everything lined up just like it's supposed to be, and everything's right when you're through.
And it's not like electrical stuff.
The front end work, like you and Tyler are doing over there, it's taking you all a while to do that, but you're learning a heck of a lot about the alignment angles when you're trying to set, when you're looking at caster and your camber, and you're seeing how when you set one and you get it perfect and you make another adjustment, it throws this one off.
Yeah.
So you have to learn how to do that the right way. See, and it's a good thing that you guys are sticking with that. Although I don't see Tyler doing it.
He's on his way.
He's on his way. That's a good thing. All right. So what this for? You asked what the numbers meant. Let's talk about numbers meant. On this 4RFE, we're going to talk about 4 forward speeds. That's what the first 4 is. 5 is the relative torque capacity. R is rear wheel drive, and FE is fully electronic controlled. That's what 4RFE stands for on this particular transmission. Now you're not, like I say, you're not going to be able to draw a correlation on every transmission. They have a 4R100. Used to the one in that some of these 90 and up F-Series and Broncos and all were, they had an E4OD transmission, which is a big sort of a heavy duty looking transmission. Of course, it gave a pretty good bit of trouble. The transmission mechanics liked it. This one's got an AOD in it, but the E4OD was electronic 4-speed overdrive. That's one of the things that was what that stood for. 4R100 was what that transmission became, which was the same transmission, but they just changed the number on it. The AOD changed, and I started to say this earlier, and I dropped the ball. 4R70W was what they started calling it. So they have reasons for doing all those numbers. Don't worry a whole lot about that unless you're a stickler for having to accumulate a lot of knowledge, All right, so you got a transmission case label that includes a part number and an identification code on this 4RFE, and the number stamped into the pan rail. It includes the plant code, Julian date, year built, sequence number, and the part number. And proper identification of the transmission is important if you're going to order parts or seek technical assistance. Seeking technical assistance is what the dealers do whenever they run out of ideas and they got to call the people at the hotline. It was designed to use in the 4.7 liter V8 with the 4.7 liter V8 in the Jeep, the Jeep Grand Cherokee and the Dodge trucks. And the first vehicle that had it was the 99 Jeep Grand Cherokee. And it's fully adaptive. Now, what does that mean? The control module calibration learns to compensate for differences in hardware. Okay, so it basically learns, a lot of these automatic transmissions, and this is important for me to tell you this, learns how you drive, and it changes the way it handles its pressures and all that. That's one of the things that they can do with all this heavy-duty electronics. It employs engine torque management strategy during high throttle shifts, and that results in smoother, quicker shifts. See, all right, we're going to run across a number here in a minute. We're going to run. You keep paying attention to them questions. We're going to, if there's some that you didn't get answered when I'm through telling you about this, then we'll go through that. But we're talking about a specific transmission here. Torque management means it reduces the torque that the engine is putting out at the point of the shift, and it makes it feel smoother. Because a smooth feeling shift is what it's all about. It has no internal bands. You've seen transmissions just about always have bands, right? Now, a lot of the times, instead of having a band, they'll have a brake that is actually splined into the outside of a drum, and they'll have the plates that are splined into the case, which is doing the same job as a band, isn't it? You're basically stopping and holding a component and all that. The input clutch assembly has an underdrive clutch, an overdrive clutch, and a reverse clutch. And it also contains separate holding clutches, and that would be the second and fourth clutch and low reverse clutch. And there's a mechanical overrunning clutch. Now, what's an overrunning clutch, guys? An overrunning clutch will only hold in one direction. If it gets, if you're going slower, than this thing operates, it's holding in one direction, but as soon as what is being driven is running faster, it overruns. Kind of like a starter drive. A starter drive's got an overrunning clutch. If the starter gear is driving the engine, the overrunning clutch is holding. But if you're still holding it in start when the engine starts up, that flywheel gear can spin that starter gear because it's got an overrunning clutch in it. Periodically, you could actually, we piddled around with it, but what the deal was, the transmission cooler in that particular car, if there's enough crud in the radiator, the transmission cooler gets partially submerged in sludge inside the radiator so that it's not able to get rid of its heat. Then the transmission slowly begins to overheat. So what do? We take a cooler that you buy from the parts house, which is a bunch of tubes that are snaked through some fins, and it's got two outlets, an inlet and outlet on it. And we unhooked the hoses from the transmission cooler, and we ran it to this, and we put it outside. I did a fluid change because the pressures of the properties of transmission fluid change when it's been hot, and it gums everything up. Change the fluid, put a modulator valve on it, which is actually the vacuum operated, deal that goes on there. It helps you hold your gears whenever you're heavy throttle, low vacuum, high engine load, holds the gears longer. We put a new modulator valve on there because that one there had a little oil. So we put the transmission cooler, took care of the problem. We had decent cooling, and where does the heat come from in an automatic transmission? Who can tell me that?
The heat.
Yeah, where's the heat made? Where does it make the heat at?
In the transmission?
No, it does not. Not in the transmission. Yeah, the heat's made in the torque converter, which is technically part of the transmission, but down inside the transmission, that's not where the lion's share of that heat is made when that torque converter is shearing the fluid. See what I'm saying? That's why I told you if you're sitting in traffic and you got it in drive, and it's on a hot summer day, and you just sit there in traffic and drive for an hour because there's a traffic jam, it's going to heat the transmission up. It's going to puke fluid out of the van.
That's why you always drive a manual.
Put it in. Well, if you got your foot on the clutch, you may burn something out that way too. So.
Yeah, I have to put it in neutral.
Yeah. And if the fluid gets out of a manual, it wipes out all the gears, and you have to have a new manual transmission.
Not necessarily.
Yeah.
Sometimes you just put more fluid in it.
Yeah.
It'll just get stuck in
Only
again.
if consistently do that and keep it full.
Yeah.
If it ever, it always completely loses all of its fluid because there's one time you forgot to do that, and then all of a sudden it wipes it all out.
I know whenever I first got my car,
I mean, that's the way it happens. People say, well, I'll just keep adding some fluid, and then they forget, and the next thing you know, you hear down in the transmission, oh no, and then they put oil in there and it still don't fix it. Oh man.
well, mine never made no noise, but when I first got it, it ran out of transmission fluid.
Well, don't worry, it
stuck
will.
in fourth gear.
Yeah.
That was not fun.
All right, so you got 3 planetary gear sets in this transmission, and that's one more than you're used to seeing in most transmission nowadays. They provide a deeper low gear ratio, and this 4RFE doesn't need a separate overdrive unit. And so the unique characteristic of it is alternate second gear ratio, or 2'. That 2' gear is enabled only during kickdown shifts. So it only uses that when you're doing a kickdown shift, which is pretty cool. It allows a lower passing gear at highway speeds, and it shows the different gear ratios are your 3-to-1, that's in reverse, and in first. 3 to 1 is in first and reverse is 3 to 1. Second gear is 1.67 to 1. Right? This other one, if you'll notice, the one when you kick down, the kick down, when it kicks down to second. Now this is what I'm trying to tell you. When it shifts up through its gears, first, second, it's going to go from 3 to 1 to 1.67 to 1. That's second gear. But when you kick down, it drops down to 1.5 to 1, which is another second gear ratio that's a little lower, and it's only used for passing gear. The only time it ever uses that one.
We just got the answer to one of them.
Huh?
I think we got the answer to one.
There you go. It's only used for passing gear.
See,
All right. So and then you got 1 to 1, and for third gear, obviously, and then you got your overdrive gear, which is 0.75 to 1. It's got some features that really set it apart from other transmissions. It's really unusual. The torque converter has got needle-type thrust bearings instead of, the one that we took apart in here that we could take apart. It's just got, kind of like fiber thrust bearings in it. Of course, there is a needle bearing on the stator on that one. It's got a dual-stage fluid pump. It's got 3 gears, 1 drive gear and 2 driven gears. In other words, the fluid pump is really cool because instead of just having, it's got usually you'll have a gear. You'll either have a crescent gear that's got a little sort of an island here next to it, and it's turning through like that. In other words, this gear will be driving an outside gear, and there'll be a crescent between there. Or you got your gyrotor gear, which is like that right there. I mean, it's actually doesn't have I don't want to have to try to draw these, but it'll have a gear like that that's turning through. And what it does, it pulls fluid in over here on one side, and whenever it gets around over here, the hole's closed up on that side, and it can't do anything but go out. See what I'm saying? So basically, you got one like that. This one here has got it's got gears like this. It's got 3 gears. It's a real unusual fluid pump on that thing. So it's at higher speeds, only the primary stage is needed to supply the pressure, and the secondary stage is put into recirculation. So it actually recirculates. The pump assembly's got control valves, which are like converter clutch switch valve, a converter clutch regulator valve, and there's a pressure regulator valve, the torque converter limit valve, and these were previously found in the valve body, but they've moved them to the pump in this one. When you put those valves closer to the pressure source, it improves line pressure control, makes it better. Their position in the pump assembly eliminates some of the hydraulic circuit from the valve body too, makes it a little simpler, and that's a good thing. The 4RFE's valve body directs the flow of the transmission to a planer, but release the clutches. You've seen that before. All right, so you got the manual valve that directs fluid to the appropriate hydraulic circuit based on the position of the shift lever. The one that you move. The one you had to put your little S-link into whenever you put it in gear and all that. That's the manual valve, the big valve that moves when you move that. James Pound was putting a shift kit in his Chevrolet pickup when he was here, and he dropped his manual valve and bent it. You will never, ever straighten that sucker out. I mean, so that it'll work smoothly. I mean, it just ain't going to happen. So he had to buy him a $54 manual valve to replace it. Well, he actually, he didn't just drop the valve. I think he dropped the valve body. And it bent, and it was his valve body on his truck, and there wasn't nobody helping him, so he couldn't blame it on anybody but himself,
I would have still blamed it on somebody.
Well, you probably would. Okay, so
blame it on Lawrence.
anyway, so you got the manual valve's got 4 positions: park, neutral, reverse drive, and 2 low, and RFE. And it holds for low reverse switch valve. The valve body also has a low reverse switch valve, and that separates the circuits for reverse and all other manual valve positions. This stuff sound like Greek a lot of the time, too, if you're fast as I'm going, but don't worry, it's all in the book. Valve body contains a solenoid switch valve. We're getting down, up close and personal with one particular transmission is what we're doing. And that routes fluid to either the low reverse clutch or the torque converter clutch control port. And park, neutral, low, low reverse solenoid. You got, and think about that. How many solenoids we got? Have we talked about that yet? We hadn't, have we? That's our first question, isn't it? All right, we're going to still go over those. Okay, so the valve body's got accumulators, which soften the shifts and that kind of thing, and they provide gradual clutch pressure cushion, and that's what they do. They got check balls, and that dictate the directional flow of hydraulic fluid. A fluid can't flow backwards against a check ball. When a check ball is in place, the fluid is not going to go one way, but it ain't going to go the other. It's like a one-way valve. A check ball is like a one-way valve. You got to use the shift solenoids to route fluid through the valve body for the appropriate clutch circuit. Okay, so we're going to look at the clutches. Located behind the fluid pump is the input clutch assembly, and that consists of underdrive, overdrive, and reverse clutches. Okay, so further back in the transmission, we got the fourth and second holding clutches. The lower reverse holding clutch is near the rear of the transmission. And to achieve the different gear ratios, it applies different combinations of 2 clutches at a time. That's interesting, isn't it? 2 clutches at a time. Okay, so in park and neutral, only the low reverse clutch is applied. In reverse, the 3-to-1 gear ratio is obtained by applying the reverse clutch and reverse clutch. So you got to know which clutches are applied. You're going to have to find out about which clutches are applied in order to know what's going on. If you've got a gear that's not working, and you're going to look and see what clutches are applied in that gear, and you're going to be able to target that particular gear when you tear it down. In first gear, your underdrive and low reverse clutches are applied, and overrunning clutch is active. The low reverse clutch is released when the output shaft speed reaches 150 RPM. And in second gear, the underdrive clutch and second clutch are applied together. This is going to be something, I'm going to have to give you a verbal test on this, Brandon, so make sure you memorize it all, okay? In fourth gear, in overdrive, the overdrive and fourth clutches are used to obtain a final drive ratio of 0.75 to 1.
What about third gear?
Third gear, let's see, we got to make sure we know what we're talking about here. Third gear, the second clutch is released and the overdrive clutch is applied with the underdrive clutch. Got that? Is that a question? In third gear, the second clutch is released and the overdrive clutch is applied with the underdrive clutch. You understand that? During some of your kick-down shifts, the 2 prime gears obtained by employing underdrive and fourth clutches. When the gear selector is in manual low, the underdrive and low reverse clutches are applied. And so you got there's a chart here that I can, show you. As a matter of fact, I think this handout is in that computer over there, if I'm not mistaken, if the work study student put it in there. You got 3 planetary gear sets. I've already talked about that. Now we're getting over here to where we're going to answer our first question. It's fully electronically controlled. We need to familiarize ourselves with these. Well, they're not new now because this transmission's been out 10 years. The advantage of the electronic control is very consistent shift quality with the driver feeling better shifts overall. Electronic control, like shift points and line pressure, can help improve durability, make a transmission last longer. Electronic control facilitates the diagnosis of suspected transmission problems. One of the cool things about Chryslers is what you have is you got a situation where you can pull your scan tool in there and pull up your clutch volume index on the transmission. And if you got a high number on one of your clutch volume indexes, then you know that particular clutch pack is trying to slip. And it's having to put more fluid pressure in there to keep it. But it can keep track of how much fluid pressure it's putting in there. See, it's got feedback. It knows what it's doing. It knows that if the gear ratio is not right, it says that clutch may be slipping a little bit. I'm going to put a little more fluid pressure in there, and I'm going to record that so that whenever my technician plugs his scan tool in, you may see something that look at your clutch volume indexes will look like 40, 50, 70, and 150. If you got one that's really high like that, you know that clutch is slipping.
You got to be driving it when you're doing it?
No. It's in the memory. It just keeps it there. So when you plug the scan tool in, you can go in there and test. Chrysler is the only people that do that I've ever seen. Now, there may be another transmission out there that I don't know about that's doing that, but that's basically an interesting way to do that. I don't know if I remember telling you about some of these transmissions that had the fuzzy logic. They know when the cruise control was engaged because of the way the electronics were set up. And heck, this was back in the early 90s on some of the stuff that we had that was Japanese. It seemed like it was, I can't remember which cars it was. It was some of this Chrysler stuff that was probably made by Mitsubishi. It wouldn't downshift, even though the throttle angle and the engine load dictated a downshift. If the cruise control was engaged, the transmission computer would not downshift because it knows that customers are trying to save gas and they don't want to downshift. They don't want you to downshift. If there's any way you can make this happen without a downshift, we don't want it. And so they called that fuzzy logic, and it was programmed into the computer. If the cruise control's engaged, huh?
We went over that one time.
Yeah, exactly. We talked about it, but I burn it in, and not everybody's here every day. But so that's what you're talking about there. And this right here is basically, this transmission control system is sophisticated enough to do stuff like that. So anyway, the TCM's under the hood and handles all the transmission control that was previously the responsibility of the powertrain control module. You remember the other day on that Cobalt, what I was talking about, it wouldn't, the speedometer wouldn't work and it wouldn't shift out of low. Remember that? Okay, the transmission computer on that one was separate from the powertrain control. From the engine control module. If the transmission control is separate from the one that does the engine, you can technically call the engine control module, you don't have to call it a PCM because it's not controlling the transmission. You call it ECM. See that? You can call it that even by law, by the 1930 regulation. But So what we wound up with on that one was that little bitty transmission computer that wasn't any bigger than, my gosh, it was a little tiny thing with a 49 wire connector plugged into it, one big wire and a whole bunch of little ones. And so I go in there and I look in the wire schematic and I find out, okay, power and ground goes in on this wire and this one, and I check power, got good ground. Okay, does it even know that the vehicle is moving because the speedometer didn't work? See, of course, I also had a transmission computer that wouldn't talk. So it wouldn't talk, I want to know if it's powered up. It was powered up. It had plenty of power and ground going to it. Any module that won't talk, you want to see if it's powered and grounded. Real important. You also want to make sure if it is powered and grounded, but it won't talk. Let's say it's powered and grounded, but it's working, but it won't talk. You want to see if the network wires that go from the module to the DLC under the dash, are they cut? Or if somebody, I have seen people get under the dash when they're rooting around trying to find a wire to wire up a radio, snip, cut some of those wires. And now all of a sudden your scan tool won't talk to some of your modules. Now they still work. The module may still work, but you're trying to pull a code because you suspect something going on there. You got to be able to recognize. Look at the big picture, guys. Okay, we had power, we had ground, but we had no communication. We had no speedometer operation. The speedometer operation, the speed sensor on that Cobalt was hardwired to the transmission control module, and the speed information was sent to the instrument cluster on the Class 2 signal line. See, so I had like 9,000 ohms coming from my vehicle speed sensor, and I had a good signal coming up that way, all the way to the connector. I'm checking it right here, the transmission connector. I'm not checking it at the sensor. I've got everything I need right there, but this thing's dead as a hammer. And so I call over here. They get me a used one, $100, and pop it in there. And we got speedometer. We got we got shifts and everything. Didn't even have to program that one. Now I don't know on that one. You may have had to program it if you bought one from Chevrolet, for tire size or something, so it'd be accurate or whatever. And so it always got to, when you're replacing a module nowadays, it's not always a plug and play. I'll tell you about this. You guys remember, I know y'all have talked about this a bunch of times. Ethan and them, when they were here, the guy that you were talking about that you saw over at Performance, he actually, I got Cindy Green had this Trailblazer, and the module on the door was going click, 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 and the windows wouldn't work right and all that stuff. So we got another one of these for like $125. The switches that go in the door and all that, old big assembly there. Plugged it in. Well, that was a computer. It wasn't just switches. And so when we plugged, they made sure there was power and ground and everything come up there, and then they plugged it in. It still wouldn't work. Or it wouldn't work at all. It wasn't clicking, but it wasn't moving no windows or nothing. All right, so they had to, what I did was I sent it up to, I didn't have the stuff to program it at the time, but I sent it up to J.M. Jackson for $20. They plugged their stuff into it and they programmed it, and now they're working fine. I mean, that was what was wrong with it, but you had to program it to make it work. And you wouldn't think you'd have to do that with power window switch assembly. But you had,
doing it too on that camera right there.
$200 just for the switch. All right, so what you're going to enjoy. But anyway, what you're going to have here is a lot of these kind of situations like that where you got to program the stuff. Something else I'll tell you that was really funny. Listen to this. Bobby, this guy that's got this really nice Avalon. That's Bobby's a maintenance guy. He says we had done some work, cleaned his battery terminals or something. I can't remember what it was. And all of a sudden he said his sunroof wouldn't work.
Oh yeah.
Remember that? Remember that deal?
Yeah.
Sunroof wouldn't work. And so I went in here and I looked around and it didn't fix. And it didn't fix is a wonderful thing. And you have to reprogram all the windows so that it will know where they stop and start. And once you get the windows reprogrammed, now the sunroof will work. But the sunroof wouldn't work until you program the windows. And you didn't program the sunroof.
Because we had like the battery cables off longer than 15 minutes.
Or something like that, yeah. But what happened was that was not anything you had to do with a scan tool. You just had to know how to operate your switches and do things to program the window so that it could find where the bottom and where the top was. Because you got smart motors.
Yeah.
You see, it's not just a reversible DC motor. There's more to it than that now. All right, so your TCM has got sensors and switches to determine the appropriate gear ratio and schedule shift points. It uses outputs like shift solenoids to perform the actual shifts. It communicates with other control modules over the vehicle's PCI data bus, and it does have 5 shift solenoids. It is flash reprogrammable, like most of these things are. It juices up the EEPROM in the computer with 18 volts, wipes out the program, writes it back in there. Not a very big file, doesn't take long to do in most cases. Some of these Jap cars, Volvos or something, Joey Hendrick out there in Russell, Kansas does this all the time. All he does is programming stuff. And he said some of these Volvos and stuff will take 8 hours to reprogram, to reflash. It's incredible. You have a special battery charger with no ripples. I got one of those. You hook it up and you gotta just be patient. Just let the thing sit there, and it's going to take all day long. You better hope you don't lose power. But it just wipes everything out. Yeah. Joey was a phenomenal character about being able to just bring a bad module back from the dead, though. He figured out ways to do that nobody else knows. Okay, we'll look at the direct inputs. That's the ones that are hardwired directly to the computer. The transmission computer receives power input from two sources, fused battery power and fused ignition switch input. It's got power all the time, and it knows when you turn on a key. And that's it's not just sensing when you turn on the key, it's using that power for stuff. And it also has a ground, which you got to have a ground to complete any power circuit. The input speed sensor reads input shaft speed off a tone wheel. This is nothing mysterious about that. We've all seen that plenty. And it compares that reading with that of the output speed sensor. So you got basically input shaft speed, which is what? What else we call the input shaft? What's the other name for the input shaft in the transmission? Huh? Turbine shaft. Good answer. Turbine shaft, we're going to measure the speed of that, and we're going to measure how fast the output shaft speed are going. We're going to compare those. When we know we're telling it to be in a certain gear, we know how fast those are supposed to be turning, don't we? We're also paying attention to how fast the engine's turning. But for the transmission's purposes, how fast the turbine speed is turning is all important. That provides the TCM with gear ratio information, and the crank position sensor supplies it with engine RPM data that's critical to schedule and shift point. Now that typically is, on most systems, that's piped in from the PCM. It's not typically hardwired to the TCM. In some cases it is, though. Now the shift solenoids, you got the shift solenoid pack. Now a lot of times on these Chrysler transmissions, particularly the front wheel drive ones, they have a solenoid pack up on the front of it. And it's really, you're thinking, oh, transmission solenoids, you're thinking pull the pin, valve body, and all this kind of hogwash. Well, on a lot of these front wheel drive transmissions, I mean, I'm not talking about this one right here necessarily, because this one's inside. But on some of them, it's on the outside, right up there in the front. Not that hard to change. $150. You buy from the parts house.
Sit on top of the transmission?
Yeah, right in the front. Not on top of it. It's kind of in the front, right on the very front of it. But when you pull it off, you'll see you need to clean it real good so you don't have dirt and stuff getting down there when you pull it off. Because a lot of times they'll have dirt clustered around it.
You got one laying around?
I have one of those. As a matter of fact, I think I got one over here.
And my auntie, Van, she said something about a solenoid messed up on it.
This one.
They said it won't shift.
Yeah,
That's right. Bolted to the.
That is bolted. That's right on the front of the transmission. It's got this little computer with it, and those little solenoids are in there. And see how what I'm saying? It's got the bolts right here. Got 3 bolts right there. And I've actually got the cover so you can see it. I should have already done it. And it ain't got that many wires going to it. But you got to get the right one for that vehicle. See what I'm saying? Mm-hmm. And then, of course, they got a big sign on the front that says removing the cover can alter calibration, replace, do not repair. So. But anyway, that's what you can look at that. That is not hard to change. You got to make sure you got the right gasket with it. It'll come with it. But unlike a parts house, has got one of these for like $150.
Yeah,
and a lot of the times you'll draw a code. They'll throw you a code and it'll tell you got shift solenoid issues. And I told one student in here, I said, we need to put one of these on this transmission. What are we going to do if I don't fix it? Everybody wants to, think all the way into infinity. What you going to do if I don't fix it? What you going to do? Well, you start with what you know. And these things right here crap out all the time. We put that one on there, and they were gone.
Did it come off a van?
It came off of if it's a Dodge Caravan. Dodge Caravan.
Van is a Chrysler.
Yeah, exactly.
Like a 2002.
It's going to have one that looks almost just like that on it.
Yeah.
Yeah, Town and Country or what?
Yeah.
It's what you're going to be looking at right there, in all likelihood. But those and the speed sensors on those things, them big plastic speed sensors, they like to crap out too. They don't cost all that much. $30.
That'll cause a van just to be in one gear all the time.
It can do that, Yeah, but make sure you pull your scan tool and make sure that they ain't gonna blown fuse. Blown fuses can cause it to be in one gear all the time too.
Yeah, that's what I told you.
Yeah. So. But anyway, so there you go. Besides the shift solenoids mentioned earlier, the solenoid pack contains several different inputs. It's got a transmission range sensor with 5 switches to tell the TCM through different combinations of switch states what the position the gear selector is in. You remember the little worksheet I gave you guys on the digital transmission range sensor? How many of you have not done that? Digital transmission range sensor worksheet.
Talking about the breakout box one?
Huh?
That's the breakout box one?
The breakout box one, where you're actually looking at the different states. And I drew this little matrix here that we did, and we had 4,
the binary map.
and then we had park, reverse, neutral, drive 1, and then we had 2. And at each one of these switches, as they're closed or open, it'll be closed or open in different states. And that's like a 4. This one's got 5 switches instead of 4. So what would those be? If it's got 5, what are the binary code going to be? It's going to be 1, 2, 4, 8, 16, right? And so you're going to have various different combinations of ons and offs, and it's going to add these numbers up, which is a binary code thing. That's how that thing works. And see, the computer knows which is which, because computers add and subtract really fast. You know, you think they can multiply and divide, but they use addition and subtraction to make it happen. That's how that works. All right. The transmission temperature sensor is a thermistor that TCM uses to monitor the temperature of the transmission fluid, because it has to have different, strategy of controlling the pressure whenever the fluid's cold. Okay, the solenoid pack, which is what, you're talking about. This one here is inside up in a valve. I mean, it's not on the outside of the transmission, it's up in the pan. And it's got hydraulic pressure. It looks at, it's got switches that look at the hydraulic pressure in each clutch circuit. That's the feedback for the fluid pressure. And these TRANS transmissions, well, like that Sable, the Mercury Sable out there has got transmission. It's got switches in the transmission. And they look like little oil pressure switches in that Sable. Like for engine oil pressure, there's a bunch of them screwed in there. Isn't that cool?
I'm sure.
Yeah.
I was looking at this. I took the cover off to look at this up.
Mm-hmm.
So basically, when you're energizing these, it's pushing the solenoid.
Yeah, it's changing. Yeah, it's changing the passages that go to the holes.
Okay.
Another direct input at the TCM is the line pressure sensor, and that uses it to read line pressure, main line pressure. That's a transducer. And because the transmission computer uses throttle angle when scheduling shifts, the throttle position sensor is hardwired to the transmission control module. Think about that. The throttle position sensor is hardwired. And so the overdrive off switch cancels overdrive operation. It's also a direct TCM input. So you got all these. Now you got some indirect ones. In addition to the inputs wired directly to the TCM, there's other inputs it obtains from other control modules over the PCI bus. And that's a kind of bus that only Chrysler used. It's like a one-wire bus. They go indirect inputs, or what you're going to call those, because the other modules are sending those inputs to the TCM, and it's using those to make decisions. Even though it's not hardwired, it's still getting that information. So if the bus is down for some reason, the transmission control module won't be able to receive those inputs. So the crank position sensor is a direct input, believe it or not, on that one. It also gets an engine RPM reading in addition to crank position. So you got an indirect input to the TCM, manifold pressure, which is read from the map sensor. Remember the old modulator valve used to use that. What's manifold pressure good telling us? What do we know? Why does a transmission control module need to know manifold pressure? Can anybody tell us that? Engine load tied directly to manifold pressure?
Yeah.
Engine vacuum drops with manifold, whenever you got more load, you got less vacuum. Okay, in other words, less vacuum equals more pressure, see? So if you got, so on and so on. But the TCM uses manifold pressure reading as a factor in calculating torque and prevent grade hunting. You know what that means? What I was talking about a while ago. Grade hunting. Whenever you're actually, and it's not just when you're using cruise control, but anytime you're on a grade, when you're going up and you're holding a steady throttle angle, it's looking at engine load, and it's going to take engine load into consideration when it decides whether or not to downshift and upshift. Because you don't want this thing hunting up and down through its gear. Whenever you're going up, it's just aggravating when it does that. The TCM gets the target idle speed, compares it to actual idle speed over the PCI bus. Target idle speed and actual idle speed. Why are those significant? Target's what it's shooting for. Actual is what it's able to get. So if you've got a target idle speed of say 800, but the actual idle speed is 950 or 1200, there's some kind of air leak or something going on there. We're talking idle speeds now. Okay. All right. So it uses engine and coolant temperature sensor reading, which it gets from the PCI bus and the PCM. To calculate transmission temperature if the transmission temperature sensor is out of range. So it says, if my transmission temperature sensor is dead, then I can use engine temperature to pretty much figure out what my transmission temperature is. Right? Because the coolant and the radiator in most cases is going to be, all of it's going to be pretty much the same. Let me tell you this, when you plug a scan tool in, then you compare a whole bunch of sensor readings, transmission temperature, intake air temperature, engine coolant temperature. If the engine's been sitting there for 4 or 5 hours, they ought to all be the same. If you got one that's out of range, something's wrong with that sensor. Got that? That ain't complicated, is it? The brake switch state is another indirect input, and the TCM engages the torque or disengages the torque converter clutch when the brakes are applied. So if you want to see if your torque converter clutch is engaged, you can watch your tach. And keep your foot on where it is on the gas. And if you reach over your other foot and tap the brake and see if the RPM goes, see if it jumps up a little bit. See how that works? All right, the brake switch state is what does that. And it adjusts the transmission shift schedule when the vehicle speed control system's on. See, that schedule is different with speed control on. See, that's what we're learning here. It's also an indirect input. All right, I'm trying to go through this pretty quick because we got lots of work to do in the shop, so hang with me. Okay, so we got all these inputs. All right. We got hardwired inputs, we got indirect inputs, all that. You got all those memorized? No. Yeah. Is the let me ask you this: is the crank sensor input a hardwired input, or is it coming from the engine controller? You remember? Their eyes were glazed over and they weren't paying attention. They were thinking, if you'll just shut up, we can go out in the shop and start pulling wrenches, right?
I'd say hardware.
Yeah. It's harder. It is. He's right. He's exactly right. But it also reads RPM from the engine controller, so it gets both of those. You see what I'm saying? Remember that. There's going to be a verbal test. It's going to have all your final verbal test on this transmission. This is the one that we're looking at in depth. All right, direct TCM in outputs. Now we're talking about outputs. Inputs and outputs. It's all about computers. All right, you got to watch this. There's questions being answered here from your test. They include the transmission control relay. You got that? That's an output, which the TCM energizes to provide power to the pressure switches and shift solenoids. You got a TCM relay that's going to power up all your switches and solenoids. You got that? That's what relays are good for. The engine controller can turn a bunch of stuff on by just making one input. Click, everything comes on. All right, so you got a relay in your box out there for that. All right, the solenoid pack of the TRS assembly consists of the transmission range and temperature sensors, pressure switches, shift solenoids. The solenoid pack TRS assembly utilizes a 23-way electrical harness connector to link up with the transmission control unit. 23 wires go through that thing. The solenoid pack's got one pressure control solenoid and 6 shift solenoids. 6 shift solenoids, right? Wow. I said there was 5 earlier, didn't I? Looks like we got 6, don't we? Son of a gun. We got 6. Yeah, that's on page 8 in case you're wondering about it. All right, to control hydraulic pressure applied to the clutch packs, it turns the shift solenoids on or off depending on the desired gear. And the default position, now what's this? What's default mean? This is where it goes if it's not powered up. This is where it goes if it's not powered up. The default position of each shift solenoid varies. When it's de-energized, some solenoids are normally applied, and that allows fluid to pass through the clutch, and some solenoids are normally vented to route clutch fluid back to the sump. What's the sump? Somebody tell me what the sump is. Does an engine have a sump? Isn't that the place where the pump gets its fluid? Where does the pump get its fluid? Where does the engine oil pump get its fluid? You guys know enough about engines to know that. Out of the dadgum oil pan.
Yeah.
You know, is that the sump?
Okay,
that was, well, I know not what you'd call it, but you know, we're talking engineering stuff here.
Okay.
And they actually, the place where the place where the fluid comes from, that the pump, you know, where it sucks fluid up, they call that the sump. You know? All right, so yeah, huh? Yeah, SUMP, sump. Yeah. Another direct input, TC input, is the electronically modulated converter clutch, or EMCC. Now, if I ask you in 5 days what EMCC is, can you tell me electronically modulated converter clutch? Can you spit that word out for me?
I might stumble over it, but I'll get there eventually.
Yeah, the TCM, can you say rubber baby buggy bumpers? Can you say that? Rubber baby buggy bumpers. Those girls in the office couldn't say it. They stumble all over those words. Can you say it?
No.
Give it a try. Can you do it? Tyler's usually pretty good at this. Do it, Tyler.
Huh?
Rubber baby buggy bumpers.
Oh, yeah, I can say it.
Rubber baby buggy bumpers.
Yeah.
Say it. He bubbles on. You say it.
What again?
What? Rubber baby buggy bumpers.
Rubber baby monkey.
Rubber baby buggy bumpers. Can you say it?
I ain't even gonna try.
Well, listen. All you got to do is say rubber baby buggy bumpers, and when you see your ex-girlfriend, go by her and say rubber baby buggy bumpers. And she'll get frustrated because she couldn't say it in the office a while ago.
There's a lot of things that girl can say.
Well, what happened is she'll probably slap the taste out of his mouth. Okay, now let's see here.
Probably would.
Yeah. All right, the TCM varies the duty cycle. Listen to this. The TCM varies the duty cycle of the LRCC. What is that? What is that? Low reverse and converter clutch? You know something I thought was funny? I was actually doing some troubleshooting with the Genesis on a transmission in a Chrysler product. And whenever you're talking about in a transmission, if you see the term, like if you see a code that says Listen to this. LR solenoid. Now we're talking about a transmission, okay? Now what are you thinking?
I'm thinking left, right solenoid.
Yeah.
Left, right?
Left rear.
Oh, left rear solenoid.
Yeah, that's exactly what the people that typed the thing for Genesis were thinking. And that was like, whoa! It was low reverse.
Okay.
And a transmission, not left rear. You see? I mean, it's confusing, I know, but because they use LR, you know.
Well, if they had one that said RF, then I'd be, right front.
Yeah, exactly. But they didn't. It was like, and when I looked and it had the words, it said left rear solenoid. I said, wait a minute, there's no left rear solenoid, so low reverse. Okay. The transmission controller keeps the LRCC solenoid at full on, which is low reverse and converter clutch, I guess. Whatever. All right. Now then, it's got a couple of indirect inputs which it broadcasts to other modules over the PCI bus, and one of them is the Perndl state. What's Perndl?
Neutral
What is
loop.
it? What's Perndl? Huh? What'd you say?
Reverse drive, neutral and loop.
Click,
Yeah,
click,
your
click,
gear
click.
shifter.
Yeah, exactly.
Yeah,
Perndl. That's what I call a Perndl state, PRNDL. And that's used by other modules to sense the manual lever position. Why do they need to know that? Why do my other modules need to know the position of the shifter?
So you know what video you're gonna get.
Well, I need to know if I'm going to start the car or not.
Yeah.
Like for park or neutral. I need to know if I need to turn on the backup lights
Yeah.
and all that. So, see on that car that these little Chevrolet Impalas and all that, when you mash the brake and your stoplights come on, it ain't because the brakes are turning on the stoplights, because you mash the brake, the body computer saw you mash the brake and it turns on the stoplights. So there's all that stuff in between.
Oh, okay.
And it also sends the signals over here so you can take it out of gear and all that. So keep all that in mind.
I know Wes got me good when we
Yeah.
did that. When we wired up my cigarette lighter,
Mm-hmm.
asked him, I said, you plug the partner safety switch back in? Yep. I get in there.
Wouldn't come out of gear.
I'm like, you didn't plug it back in.
He dropped the ball. The other one is the transmission fluid temperature, and that's monitored by the PCM. Based on the transmission fluid temperature, the PCM may energize the vehicle's electric coolant fan. Listen to that. Did you know this? If the transmission fluid gets too hot, the PCM may turn on the coolant fan.
Yeah.
Even if the engine coolant is not all that hot. If you, let's say this. Let's say you're looking at your scan tool and you're saying, well, my coolant is not that hot, but it has kicked the fan on. Why would it turn on the fan? And then you look and you notice your transmission temperature. You've been sitting here with it in park. I'm in reverse or in drive a long time, and it's up to 240 degrees, and you hear the fan kick on, even though the engine may be running at 190. You say, it's not supposed to come on. So there's a lot of stuff our computer's doing that you need to know about.
Put on the transmission.
Huh?
You got fans you can put on the transmission.
Not really. I mean,
I got transmission coolers.
yeah. You got a cooler that goes in front of the radiator that's got the fluid pipes through, but But you'd have to have some fins or heat transfer stuff. They do have funky covers for the differentials on some of these vehicles that's got cooling fins in them. On the back of the differential to keep that and cool it off a little bit. All right, mechanical and electronic components as well as TCM inputs. Okay, you put the electronic, not electronical, and mechanical operation together. It works like this. The TCM takes inputs into account to determine what gear the transmission should be in. Right? And the main factors affecting the shift schedule include gear selector position, input speed sensor, and output speed sensor readings, overdrive off switch seat. In other words, if you turn off the overdrive, it's going to be different. The throttle angle from the throttle position sensor, and the temperature inputs from the transmission temperature sensor, the ECT sensor, and the battery temperature sensor. Whoop, whoop, whoop. Battery temperature sensor. Where in the Sound Hill is that? Where's the battery temperature sensor? You ever heard of one? You have one.
Is it inside the battery?
It's inside the battery. How you hook wires up to the side of the battery or something?
Yeah.
Most of it now. Sometimes they just infer it from the temperature of the engine compartment. But a lot of these Chryslers have got. If you pull the battery out, you'll see a funky little springy thing. Looks like a button in the bottom of the battery tray. That's the battery temperature sensor, and it rides against the bottom of the battery. And
Can we pull Brandon's whoop in here and take the battery out and look?
if we want to, if he'll let us. All right.
We don't care if they're going
But you'll see that. You're not going to see that on just any and every car, but you will see it on Chryslers and Dodges. Chrysler and Dodge, you got some pretty slick electronics on. Okay. The valve body directs fluid to the solenoid valves and clutch circuits. The TCM controls clutch application by energizing different solenoids to get your gear ratio. And it monitors, listen to this, mainline pressure through the pressure sensor, adjusts the pressure with the pressure control solenoid. I will tell you, and I've got a video here somewhere that I may have showed that to y'all where I rode down the road with Michelle Taylor on her Jeep. And the target pressure for her line was different Remember that? And that's what we're talking about here. It was exactly that same transmission that we're talking about. All right. It monitors mainline pressure and it controls it with a pressure control solenoid. If the transmission controller sees certain problems, it shuts off power to itself. Oh my goodness, it cuts its own throat. I see problems, kills itself. The loss of power to the TCM will result in a limp-in mode operation. So what is that? When the solenoids are de-energized and revert to their default positions during limp-in, if the shift lever is in drive, the transmission will be in third. If it's in manual second or low, the transmission will be in second. So if you got it in lower or second, it's going to be in second if you got it in drive. So you can shift it manually if you have to. See what I'm saying?
So it'll be in third.
That's the cool thing about that. Now then, since the 4RFE is electronically controlled, the diagnosis of suspected transmission problems is going to lean toward the electronic side as well. And you're going to use the DRB scan tool or equivalent. Now, the use of the appropriate manual plays a key role. Okay, we're going to whip through this right quick. Clutch volume index. Okay, it's what I was talking about before. And you can see that if you've got a clutch volume index that's a little bit high, it shows the fluid fill volume of each clutch circuit. And so you gotta look for diagnostic trouble codes, and since it's fully electronic, the diagnostic trouble codes are new, for this particular, that year model that we're talking about, which was like 2000, or 99. Okay, it's gonna be slightly different. The mill will be illuminated for some of them, and some of them will just have limp-in mode operation. Now that's been limp-in for as long as there's been computers. A lot of times it's so you can come in from off the road. They don't want the computer to crap out and cause you to be dead in the water. So they got what they call limp-in mode or something like that. Michelle Goolsby's car had a wire harness that was short and go into her electronic throttle body, and it would turn on the wrench light, and she would only have half throttle, capability for half throttle, because they were afraid that if it didn't know what was going on with between the accelerator pedal sensor and the throttle body via the PCM, it was afraid it was going to run away. So instead of running away, it just to make sure that nothing's going to go bad wrong, it limits her to half throttle. So anyway, so the 4RFE transmission is going to be serviced only as an assembly. They didn't want you rebuilding it at this particular time. Now listen to this. If you do replace the transmission or the TCM, you ought to use the DRB, which is a scan tool, to perform quick learn procedure, which adjusts the TCM CVI values, and perform the quick learn procedure only after replacing the TCM or the entire transmission. So there's product variability in the field that's got to be dealt with on that.
You think Michelle Taylor's Jeep's worth $3,500 that she's trying to get out of it?
Probably, but
with all the issues it's had.
Yeah, the transmission would actually be something that would cause me to have pause about that. She's probably trying to get as much as she can out of it. It's a nice vehicle, but if it's something, I'm gonna tell you, I'm not gonna. This is another thing. Unless somebody, and this includes hers, unless somebody has got a vehicle that's driving just like it's supposed to in every way, it doesn't have any problems. Unless let's say this is a particular vehicle that I know very, very well. Like if I know, Ford pickups really, really well, and I've fixed a bunch of Ford pickups, and I know that part X is always the problem for this. It's not hard to change. I know exactly how to change it, and I may even have one in my toolbox that I found somebody threw away or whatever. I say, okay, I know that this is what's wrong with this one here, and they're wanting this and all that, and they're wanting to sell it for $500, and it's like a $3,000 truck, so I'll buy the truck and I'll fix the truck. If it's a really good price, I'm going to buy it and fix it and drive it.
Yeah.
If somebody is wanting top dollar for something that's not working like it should, I'm probably going to have misgivings about that. I'm probably not going to buy it. I'm not going to pay top dollar, and that's pretty much top dollar. I'm not going to pay top dollar for something, even though on her car it probably just needs a transmission pressure control, the transducer. It's not usually, you can find one of those. It's not that hard to put it in there. And we used to have to replace those all the time when I was working at a Jeep dealer. So if you know the vehicle well enough to where you feel sure that you can pop that on there and it'll take care of it, it may be worth that. But she needs to be aware of the fact that you're not going to be able to squeeze $3,500 out of it if sometimes the transmission don't work right. And it's got other problems.
And there's no warranty.
That's how my stepdad got the Cherokee.
Do like Archie did, sell and not tell him it's messed up.
Yeah.
Oh,
Well, she got a whale of a deal on that Cobalt, I can tell you that.
Like on the 3.0, like out of the Ford 3.0 motor or 4.0 motor, whenever you crank it where the engine vacuum lines are at on the intake, had this truck, and every time you turn it over, it crank, and it died.
Yeah, that's usually an intake gasket.
And it was the vacuum cap.
It can be, and also the intake gaskets underneath will cause the fuel trims to go high and it'll make it run idle rough when it's cold. But anyway, and a lot of those have
Yeah,
that
so,
problem. And they're not hard to change. I mean, it's just.
My stepdad he bought the truck, got it out the driveway, and when he got out the driveway, it died. He pulled over, put the vacuum cap back on there, and boom, it was fine.
Yeah, that's one of those things that Book of Proverbs over it says, bad, says the buyer, and then he goes his way and boosts. Okay, let's whip over this. Let's zip through these questions real quick and then we'll be through. How many pressure switches are located? We said 6 a minute ago. Yeah, I think the answer to your original said 5. The TCM's electrical terminals mate to a how many way connector? 23. A 23-way connector. Okay, you guys got that good. Okay, in park, neutral, and low, the solenoid switch valve directs fluid to which clutch?
Is it B?
Park, neutral, and low. You remember? I went over that.
Underdrive.
Low reverse, underdrive, overdrive. What do you think?
I think underdrive.
You guessing?
I say it's B.
Remember? We went over it. Remember that? In park, neutral, and low, right? In park, neutral, and low, the reverse clutches, the low reverse clutches are applied. Okay, so that's B. What's the gear ratio for 4 RFE's alternate second gear?
C.
1.5 to 1. That's what we come up with. Which of the following is not a direct TCM input? Anybody know? Come on, think about it, guys. Pressure control solenoid is not an input. It's an output, right? Got it? When attempting to narrow down a problem with a transmission operation, you should start by doing what?
Maybe A.
How would I do a shift lever position test? That's a good thing to do. When the 445 RFE transmission is in third gear, which 2 clutches are applied?
Underdrive and overdrive.
Underdrive and overdrive. So, yeah, so we all already looked at that. All right. Now then, we're going to say, which of the following valves is not located within the dual stage pump assembly? A, manual valve, B, converter clutch switch valve, C, pressure regulator valve, or D, converter clutch regulator valve? Which one? Come on, guys. Manual valve's the one that you move whenever you move your gear selector. Your prindle stick moves the manual valve. True or false? The middle of the operating range on the transmission fluid dipstick is the target level on a hot transmission. That is true. If the shift lever is in the drive position and the 4.5 RFE transmission goes into limp-in mode, what gear will the transmission be in? Third. That's right. Very good. All right.
He took my pen. He threw my pen at me. Thank you.